A Zener diode is a special type of diode designed to allow current flow backwards when a certain set reverse voltage is reached. Hello everyone, my name is Rafael. I am an electrical engineer, and in this video I would like to invite you to have a conversation with me about the Zener diode as a voltage regulator. And to do so, I'm bringing this exercise. Let's go to it. It is wished to employ a Zener diode as a voltage regulator if Vi is 16 volts, Ri 1 kilo ohms, Vz 10 volts, and RL 1.2 kilo ohms. Letter A, calculate VL, VRI, IZ, and PZ. Letter B, if RL is 3 kilo ohms, recalculate the aforementioned parameters. With a detail, Vz is the breakdown voltage of the Zener diode. Okay, folks, let's go to the solution of it. Step 1 will be to determine the voltage across the Zener diode to check its operating state. Okay, we are going to calculate VL, which is the voltage on top of the load, and also the voltage here from this point to this point. VL will be equal to RL divided by RL plus RI times Vi, which is equal to 1.2 kilo ohms divided by 1 kilo ohms plus 1.2 kilo ohms times 16 volts, which is equal to 8.73 volts. Observe that 8.73 is less than 10, okay? Then this current here is 0. Iz is 0. There is no leakage current flowing backwards through the Zener diode. Okay? Since the voltage across the Zener diode is less than Vz, which is 10 volts, then the Zener is off. It is not operating. Let's calculate VRI. VRI is equal to Vi minus VL, which is 16 volts minus 8.73 volts, which is equal to 7.27 volts. We know that this current here is 0, and therefore the power P, Z is also the power dissipated in the component is also 0. Now let's do it all again. Recalculate for the load equal to 3 kilo ohms. We are going to recalculate it and see what happens. Okay? And then it is going to be letter B now. And it's 3 kilo ohms divided by 1 kilo ohm plus 3 kilo ohms times 16, which is equal to 12 volts. And now 12 volts here is greater than 10. 12 greater than 10. Then this leakage current here is greater than 0. And the Zener will be active as a regulator, as a voltage regulator, and will regulate the voltage as 10 volts. VL will not be 12 volts. VL will be 10 volts because the Zener will regulate the voltage at this level here. Now let's recalculate it all. VRI is equal to VI minus VL, which is 16 volts minus 10 volts, which is 6 volts. Okay, the currents will be IRI equal to 6 volts divided by 1 kilo ohms, which is 6 milliamperes. Okay, this voltage here, VRI, divided by this resistance is equal to this current. And the load current, the current that goes to the load here, IL, will be equal to 10 volts. Okay, 10 volts is this voltage here, divided by the resistance of the load, 3 kilo ohms, which is equal to 3.33 milliamperes. And this current here, this liquid current that flows across the Zener, is equal to the difference, 6 milliamperes minus 3.33 milliamperes, IZ is equal to 2.67 milliamperes, and the power dissipated by the component, PZ, is going to be equal to 10 volts times this current, and the power is 26.7 milliwatts. Okay, my friends? And when the voltage is less than the Zener voltage, then the calculated voltage will be the voltage at the load. But when the calculated voltage is greater than Vz, the diode is going to regulate the voltage, and the voltage across the load will be the Zener voltage regulated by the component. Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!